Alright guys, so let's do some exercise on the model selection. For your information, model selection normally will be combined with the multiple linear regression. Okay, so this example or exercise I take from past year exam question. So number 1, the pull strength of a wire bond is an important characteristic of electric circuits. Figure 4 to 9 show the Microsoft Excel output for the multiple linear regression analysis on pull strength Y, height x1, post height x2 and loop height x3. So means that here there are three independent variables where Y depends on x1, which is the die height, x2 is the post height, and x3 is the loop height. Okay, so you have three independent variable. So where the dependent variable is pull strength, so this one is the dependent variable. X1, X2, X3 is the independent variable. Right, number 1. Based on the p-value in the coefficient table from figure 4, identify significant predictors. How we want to identify significant predictors? The p-value must be less than alpha. Then your predictor is significant. Cool. So let's look at figure 4. So which one is figure 4? So here is figure 4. Microsoft Excel output for X1, X2 and X3 for the three predictors. So you have X1, X2, X3. P-value at the coefficient table. So this one is the coefficient table. So based on the p-value in the coefficient table here, identify significant predictors. So p-value for x1 is 0.3975. Is it less than alpha? Our alpha is 95%, so 0.05. So is it 0.3975 less than alpha? No, it is greater than alpha. 0.05 means that x1 is not significant. Okay, how about p-value x2? P-value x2 is 0.1780. 0.1780 also greater than alpha, 0.05. So x2 is not significant. Right, so p-value x3. So p-value x3 is 0.0020, is less than alpha, 0.05. So x2 is significant. So the significant predictors is only x3. Okay, so let's look at next question. So the significant predictors is x3. Okay, based on the p-value in figure 4, is there any evidence to conclude that at least one of the independent variable related to the dependent variable? When we have the word conclude, it is a hypothesis. So in multiple linear regression, what test that we want to test? We want to test is there any relationship or not between the variable. So based on the p-value in figure 4. So p-value in figure 4 here. Significant f here. So I will erase this one. Alright. So the p-value here is this one. Because we want to test, right? So because we want to test, we will use the ANOVA table. So the significant f here is your p-value. So you have to test. So you want to test, you have your H null. H null, neither of the independent variable related to the dependent variable. H1, at least one of the independent variable related to the dependent variable. So step number 2 is the p-value. So use p-value because the question asks you to use p-value. So p-value is equals to 0.0051. So step number 3, since p-value is equals to 0.0051 less than alpha, 0.05, you have to reject H null. So what will happen if you reject H null? Means that at alpha 0.05, at least one population, at least one independent variable related to the dependent variable. Okay. So because the question is based on the p-value in figure 4, is there any evidence? So when we talk about evidence, you must have your hypothesis. Okay, number 3. From the Excel output, summarize your result in the answer sheet based on the following table. So summarize the Excel output in this table. Hence, determine the best regression model and give your reason. First, you need to summarize your result. Number 2, you need to determine the best model using model selection. And then number 3, you have to give reason why you choose the best model. Okay, we have predictor, p-value, r-square, adjusted r-square, and regression equation. We look at one by one. Okay, from figure 4. Figure 4, we have x1, x2, x3. Okay, in model selection, the first one is possible model. So how many possible model you have here? You have x1, x2, x3. So means that k is equals to 3. So the possible model is 2 to the power of 3 minus 1 equals to 8 minus 1 equals to 7. So what are the possible 7? 7 is y with x1, y with x2, y with x3. Y with x1, x2, y with x1, x3, y with x2, x3, and y with x1, x2, x3. So this is your possible model. How many possible model you have? 7. 1, 2, 3, 4, 4, 5, 6, 7. So now we want to summarize the Excel output. So because of you have 7 models, possible models, you will have 7 Excel output. So let's look at the Excel output. First, figure 4. First Excel output. Figure 5 for x2 and x3. Second Excel output. Figure 6 for x1 and x3, third Excel output. Figure 7 for x1 and x2, fourth Excel output. Figure 8 for x3 only, 5. Figure 9 for x2 only, 6 Excel output. And last one, figure 10 for x1 only, 6, 7 output. So you have 7 Excel output here. So from this 7 Excel output, summarize it into this table. Okay, now let's look at p-value. P-value for x1. So which one is x1? X1 is the last Excel output. This one is for x1. Okay, the p-value is here, 0.1773, and the r-square is 0.1044, and the adjusted r-square is 0.0517. So we will put into the summarized table there. Right. 0.1773. Okay, and then the r-square is 0.1044, and the adjusted r-squared is 0.0517, and the equation is here y cap equals to 3.7677 plus 1.0972x1. Okay, put into your table. Y cap equals to okay. So next, for x2. For x2, you have to find Excel output for x2. So let's look at Excel output for X2. Excel output for X2 is here. So the p-value for Excel output is 0.3026. The r square is 0.0623. This one is adjusted r square. So from here you can get the equation. Okay, the same goes to X3. This is the p-value for the X3. R square for X3, adjusted r square for X3, and from here you can get the equation. Okay, now X1, X2. This is the p-value for the X1, X2. This is the r square. This one is the adjusted r square. So from here you can get the equation. Right? And then for the X1 and X3, this is the p-value. This is the r square. This is the adjusted r square. And from here you can get the equation. Okay. Next, for X2 and X3. So this is the p-value, and then the r square, adjusted r square, and the equation. And the last one for X1, X2, and X3, this is the p-value, and then this is the adjusted r square, this is the r square, and you can get the equation from here. So from all your Excel output just now, you have to put into this summarization, summarize of table. So here is 0.3026, 0623, so let me finish fill in this one, so you can also follow me. Okay, so for X3, 0.0011, right? For the X1 and X2, p-value, r square, adjusted r square, minus 0.3287. Okay, and then X1, X3, okay, for the X2 and X3, p-value, r square, adjusted r square, equation, and the last one is the for X1, X2, and X3. So the p-value is 0.0051, and the r square 0.5628, adjusted r square 0.4753. Okay, write down the equation. Okay, done. Done with the fill in of the table here. So now done. Summarize our result. Next, we want to determine the best model. So determine the best model. First, we need to find the model that have less variable. So because we want to have model that has less variable, we can discard this one because this one have the most variable. Right now we have 6. So first we look at the p-value. Which one is the p-value that greater than alpha? We have to eliminate because it is not significant. Our alpha here is 0.05. So any p-value that is greater than 0.05, you can discard that one. So look at p-value x1, 0.1773, greater than alpha 0.05. So we have to discard this one. Okay, also same goes to x2, 3.3026 is greater than 0.05. We can discard x2. Okay, now if you notice x1, x2, so we can discard this one. Alright, and then we can see here the p-value is 0.0011 for x3, 0.0036 for x1, x3, 0.0020 for x2, x3. Okay, we have 3 choices now. Now, all the p-value is less than alpha 0.05. Now, we look at the r-square and adjusted r-square. For x3, we will look at the r-square because simple linear regression. For x1, x3, we look at adjusted r-square. For the x2, x3, also adjusted r-square. Now, find the smallest p-value. The smallest p-value is x3 here. So, it also gives you the highest r-square. Right? So, why we not take s2 here? Well, we not take s2 because x2 is not significant. So, any combination with x2 is not significant. So, you compare x3 with x1, x3. The p-value is smallest for x3 and the coefficient of determination for x3 is the highest compared to the x1, x3. So, your best model is here for x3. So, the best model is equals to this one. Okay, so the best model is y cap equals to negative 8.9710 plus 0.5931 x3. Why? Because it has smallest p-value and highest r-square. Okay, so that's how you want to do model selection. First, you need to summarize the Excel output into the table and then you find the smallest p-value. You can discard or eliminate predictor which have p-value greater than alpha. And then any combination with that predictor also can be eliminated. We have to find the p-value less than alpha only. And then when you have find the p-value, you can look at the r-square or adjusted r-square. R-square for simple linear regression, adjusted r-square for the multiple linear regression. So, find the highest one. Okay. So, let's look at another example. Okay. In order to enhance the customer satisfaction, a supervisor in a supermarket conducted a study for the time in minutes a customer takes to check out after purchase by considering the total amount of the purchase, the number of purchase item and the customer's household monthly income. The following Excel output in figure 1 is a multiple linear regression for this study based on the data collected from 20 customers. So, n equals to 20. So, how many predictors we have here? We have amount of purchase x1, we have number of purchase item x2, and we have the household monthly income for the customers x3. So you have y, okay, time customer take to check out of the purchase, and then we have x1 is the amount of purchase, we have x2 number of purchase, we have x3 the customer's household income. So this is the multiple linear regression because we have more than one independent variable. So this is the Excel output. Okay, amount of purchase is X1, number of item is X2, household income is X3. Okay, so based on this one, test the hypothesis whether there exists significant linear relationship between the customer's checkout time and the independent variables at 2.5 significant level. Use p-value approach. So this one, you want to test the hypothesis. So your H null and H1. What is your H null? H null, neither of the independent variable related to the dependent variable. H1, at least one independent variable related to the dependent variable. Okay, step number 2, state your p-value. So the p-value is from here. Okay, because we want to make a hypothesis. So this one is the p-value. P-value, this one is for you to find the significant predictor. P-value for you to test here. Test H null, H1. Okay, so now they give you alpha 2.5%. Convert into decimal places, 2.5%. So alpha is 0.025. Right. So p-value is equals to 0.0000. 3. Since p-value 0.0000 less than alpha 0.025, you have to reject H null. So what will happen if you reject H null? At alpha 0.025, at least one of the independent variable related to the dependent variable. So done number 1. Number 2, state the coefficient of determination and interpret the value. So you have to take the adjusted R square value and interpret. So here the adjusted R square. Don't forget to interpret. State the predicted multiple linear regression model. So from here, you can get the model y cap equals to 4.1350 plus 0.0229 x1 plus 2.1825 x2 minus 0.5445 x3. Okay. Interpret the regression coefficient of number of purchase item and the coefficient of customers' household monthly income. So number of purchase item is x2, income is x3. So you have to determine your beta 2 and beta 3, and then you have to interpret beta 2 and beta 3. Beta 2 is equals to 2.1825. Beta 3 negative 0.5445, and then you interpret. Okay, number 5, predict checkout time. If the customers purchase, predict y. They give you x1 equals to 14, and they give you x2 equals to 10, and your x3 is equals to 5,000. So you have to find the y. Just put x1, x2, x3 into this equation, then you will get the y. Okay, number 4. The summary of the multiple linear regression for the study is given by table 3. Okay, they give you the summary already. Complete the table for 3 predictors based on figure 1. Then select the best regression model. Justify your answer. Okay, x1, x2, x3. The p-value? Okay, the p-value is 0.0000. So you put here 0.0000. The R square is 0.8260. 0.8260. And the adjusted R square is 0.7934. And you write down the equation. Y cap is equals to this one. Okay, so fill in the equation here. Right, now after you have filled in this one, you want to find the best model. First, what you need to discard, we have to eliminate this one because this model have the most predictor variable. So discard that one. Okay, next, we find any p-value that greater than alpha. So you look at your p-value here. All the p-value is 9.24 times 10 to the power of negative 6 means that 1, 2, 3, 4, 5, 6. 0, 0, 0, 0, 0. You convert into 4 decimal places, you will get 0.0000. So here is 0.0000. The same goes to here, the same goes to here. Oh, sorry, here is 7.8 times 10 to the power of negative 2. 1, 2. 0.078. Okay, this one is 0.0000. This one is also 0.0000. 0.0000. 0.0000. Okay, can we discard x3? So our alpha is 0.05. Can we discard x3? Yes, because x3 p-value is greater than alpha 0.05. So you can discard the x3. Any combination with x3, you can discard them. Okay, now we left for x1, x2, x1, x2. So all the p-value x1, x2 and x1, x2 is less than 0.05. So we look at the r square and adjusted r square. So r square here and adjusted r square. Which one give you the highest coefficient of determination? x1 alone, x2 alone, or x1 with x2? Okay, the answer is here. x2 alone. So your best model is this one. Why? Because the p-value is smallest and it gives you the highest r square. So the best model is y cap equals to 2.1230 plus 2.5583 x2. Why? Because smallest p-value and highest r square. Okay, so that's all for the multiple linear regression and the model selection.